Hi everyone, this is the second episode of our Python object-oriented programming course. In this one, we will learn about the constructor, we will learn about what is the double underscore init function, and we will also learn some important principle that object-oriented programming brings with it. We will also focus on something that is very underrated in my opinion when it comes to object-oriented programming, and that is using a special Python keyword that is called assert. So it is going to be very interesting to look at all of those. And I believe that this episode will give you some information that you could really benefit from and improve your programming skills. Let's get started. Alright, so until that point, we understood that we can assign attributes and as well as creating some methods that we can go ahead and use them from our instances directly, like those two examples in that line and as well as in that line. Now, in that episode, we are going to solve some more problems that we have in terms of best practices in object-oriented programming and things that you are going to see in each project that is based on OOP. Alright, so let's get started. Now, one of the first problems that we have here is the fact that we don't have a set of rules for the attributes that you would like to pass in order to instantiate an instance successfully. And what that means? It means that for each item that I want to go ahead and create, I need to hardcode in the attribute name like those in here. And it could have been nicer if we could somehow declare in the class that in order to instantiate an instance successfully, name, price, and quantity must be passed. Otherwise, the instance could not have been created successfully. So what that means? It means that it could have been a great option if we could somehow execute something in the background the second that we instantiate an instance. And there is a way that you can reach such a behavior, and that is by creating a special method with a very unique name, which is called double underscore init double underscore. Now, you might hear this term as well as called as constructor. Basically, that is a method with a unique name that you need to call it the way it is intentionally in order to use its special features. Now, the way that this is going to work is by creating it the following way. So it will be double underscore. And as you can see, I already have auto-completion for some very special methods that are starting and ending with double underscore. Now, the collection of those methods are used to be called magic methods. And we are going to learn a lot of more magic methods that you have in OOP, but the first one that we are going to start with will be the init double underscore like that. Alright, so now that we have created this method, then let's actually see what this method does in the background. So when you go ahead and create an instance of a class, then Python executes this double underscore init function automatically. So what that means? It means that now that we have declared our class, Python is going to run through this line, and then since an instance has been created and we have double underscore init method designed, then it is going to call the actions that are inside this double underscore init double underscore method. Now, in order to prove you that, then I'm going to start with a very basic print here that will say I am created like that. Now we got here one instance and here we got another one. So we should see I am created twice. And in order to avoid confusions, then I'm going to delete those print lines from here so we can see a cleaner picture. Alright, so if we were to run our program, then you can see that we have I am created twice. And that is because Python called this double underscore init double underscore method twice, thanks to those two instances that we have created. Alright, so now that we use the double underscore init function in this class, we should take benefit from it and solve some more problems in order to implement OOP best practices. Now, if you remember, in the beginning of this tutorial, I said that one of the problems that we have till this point is the fact that we still hardcode in the attributes in that way by saying .name, .price, .quantity. And that is something that we can for sure avoid. Now, let's see how we can start avoiding creating those attributes hard-coded for each of the instances here. So we can actually benefit from the double underscore init method that we have designed, and let's see how. Now, we understand that for each instance that we will create, it will go ahead and call this double underscore init method automatically. So what that means? it means that not only we can allow ourselves to receive the self parameter, because this is a mandatory thing that we should do, because Python in the background passes the instance itself as a first argument. We could, in addition, take some more parameters and then do something with them. So as a starter, let's say that we would like to receive one more parameter that we could name it name. And as you can see, automatically Python is going to complain how the name argument is not filled in here. So now I could go ahead and pass in the argument of phone for that one, and for the second one I can go ahead and pass in the argument of laptop. Now once I have created this, then I can actually go ahead and change my print line a little bit, so it will be a unique print line where I can identify from where each print line came from. So I can go ahead and say an instance created and use a colon here and then refer to the name like that. And now that we have created this, then if we were to run our program, then you're gonna see unique sentences, an instance created for the phone and as well as for the laptop. Alright, so now that we have done this, then there is something that is still not quite perfect, because we still pass in the attribute of name here and here. So now pay attention how the init method has to receive the self as a parameter as well, and we already know the reasons for that. And the fact that we have self as a parameter here could actually allow us to assign the attributes from the init method, so that we will not have to go ahead and assign the attribute of name for each of the instances we create. So what that means? It means that I can dynamically assign an attribute to an instance from this magic method, which is called _init. So if I was to say self dot name, so I'm assigning the attribute of name to each instance that is going to be created or created yet, and I'm making that to be equal to the name that is passed in from here. So what that means? It means that now I can allow myself to delete this line and then this line. So as you can see, now I have a dynamic attribute assignment thanks to this self.name equals name that we have wrote here. And to test that the attribute assignment worked, then I can go down here and use two more lines that will look like the following. So I will print item1 dot name, and I will also print item2 dot name. And in order to avoid confusions, then I'm going to get rid of this line, so we could only see the print lines from here. And now if I was to run that, then you can see that we receive phone and laptop. So it means that we were able to assign the attributes dynamically, and that is perfect. And now that we get the idea of that, then we should also do the same for the rest of the attributes that we'd like to receive. So we also got the price and quantity to take care of. So I'm going to go to my init method and I'm going to receive again price and quantity, and I'm going to do the exact same thing. So I'm going to assign the attribute of price, and that will be equal to price, and the quantity will be equal to the quantity. And you can also see that again Python complains about the price and the quantity not being passed in here. So I can say 100 and then 5, and then I can delete those. And then I can do the same here. I could pass in 1000 and then 3 and delete those. And in order to prove you that this is going to work, then I'm going to copy myself a couple of times and change this to quantity. I mean price. This one will be price as well. This one will be quantity, and this one as well. Now if I was to run that, then you can see that the results are as expected. So that is a way that you should work with the _init method. You should always take care of the attributes that you want to assign to an object inside the _init method, meaning inside the constructor. Now a couple of side notes that are quite important to remember when we work with classes. Now when we go ahead and use the _init method, this doesn't mean that we cannot differentiate between mandatory parameters to non-mandatory parameters. So say that you currently don't know how much you have from a specific item, then you can go ahead and by default receive this quantity parameter as 0, because it is realistic situation that you currently don't know how much phones you have on your store. So you can directly go ahead and use a default value for that, for example 0, And then this will mean that you will not have to pass in those 5 and 3 here. And now, in order to show you the results of that, if I was to run our program, then you can see that we received 0 twice for those two prints in here. So that is something that you want to remember. And one more quite important point that I'd like to talk about now is the fact that you can assign attributes to specific instances individually. So say that you want to know if the laptop has numpad or not, because some laptops are not having the numpad on the right side of the keyboard. But this is not a realistic attribute that you would want to assign to a phone. And that is why you can go ahead and let me delete those print lines, by the way. And that is why you can go ahead and say something like item2.has numpad equals to false, like that. And that is something that you want to remember, because the fact that you use some attribute assignments in the constructor doesn't mean that you cannot add some more attributes that you would like after you instantiate the instances that you would like to. Alright, so now that we understood this, then there is still one small problem that is left that we need to solve. Now pay attention how the calculate total price still receives the x and y as parameters. And the question that we ask now is why it still receives those parameters. Well, we could for sure now not receive those parameters, because as we know, for each method that we design in classes, then the object itself is passed in argument. And I know that I repeated this a couple of times, but this is where I fail to understand classes. So that is why it is very important to understand this behavior. And we already know that the object itself passed as an argument, so that's why we receive self. And so this means that now we could just return self.price multiplied by self.quantity, and this will mean that we don't really have to receive those parameters, because we assign those attributes once the instances has been created. So this means that we have access to those attributes throughout the methods that we are going to add here in this class in the future. So in order to test that this works, then I'm going to delete this example for now, and I'm going to say print item1 dot calculate total price. So we will be able to return the result here, and I will do the same for item 2. Sorry, only this one. Now to show some real number other than 0, then I will go ahead and pass in here quantities. So I will say 1 and 3, for example, because I don't want to multiply a large number with a 0, and that could come from here. So I will run that, and you see that we receive the expected result. So now we completely understand the big picture, how to work with the constructors in classes and what are the best practices that you should go ahead and implement. Alright, so now that we understood this, then we might think that we have done everything perfectly. But actually, I want to show you what will happen if we were to pass in here a string besides an integer and run our program. So if we were to run that, then you can see that we are screwing things up here, because this function, for example, thinks that it should print the string 3 times, because you see we have 1000 multiplied by 3 that is being returned in here, so it shows us 1000 once, 1000 twice, and then one more time. So what that means? It means that we have to validate the data types of the values that we are passing in. So there are a couple of ways to achieve this. And one way is by using typings in the parameters that you're declaring inside here. So a great starter will be, for example, to declare that a name must be a string. Now let me first take this back and change those to integer, and then go here and design those parameters. So in order to specify a typing, then you should go ahead and create a colon sign followed by the type of the data type that you expect to receive here. So if I was to pass in here only the object reference to the class of str, then it will mean that it will have to accept strings only. And I can prove you that by changing this to an integer, and you're gonna see that we have a complaint here that says expected type str got int instead, and that is perfect. So now that we have done this, then I'm going to do the same for the price itself. And price we could actually do the same thing with it by passing in float. Now, when we pass float, it is okay to also pass integers. And that is something very unique with floats and integers together. So that is okay to use the typing of float. And for the quantity, we don't need to specify a typing because the fact that we passed a default value of integer already marked this parameter as to be integer always. So that is why, for example, if I was to leave this as it is and change the quantity to a string, then you're gonna see that it is going to complain because the default value is already an integer, so it expects for an integer. Alright, so those things are actually great setups to make our init function more powerful, but we might still want to validate the received values in the following way. So say that you never want to receive a negative number of quantity and you never want to receive a negative number of price. So that is something that you cannot achieve by the typings in here. But there's actually a great way to work this around, and that will be by using assert statements. Now, assert is a statement keyword that is used to check if there is a match between what is happening to your expectations. So let's see how we can get work with assert. So I'm actually going to delete this from here, and I'm going to organize our init method a little bit. I'm going to say here a comment, and I will say assign to self object, and I will say up top something like run validations to the received arguments. All right. So now it is a great idea to validate that the price and quantity are both greater than or equal to 0, because we probably don't want to handle with those when they are negative numbers and we want to crash the program. So we could say assert, and pay attention that I use it as a statement, not a built-in function or something like that. And I can say here price is greater than or equal to 0. Now, once I set this, then I can also do the same for quantity, actually. So let me do that quickly by this way. And then once we have this, then I can actually go ahead and run our program, and you will see that I will not receive any errors. But the second that I change this quantity to -1, for example, and this one being -3, then I will have some errors that will say assertion error. Now you can see that the fact that we see here assertion error is quite a general exception that doesn't mean anything. Now, what is so beautiful with assert? You can add your own exception messages right near of it as a second argument. So let's go up top here and go back to those two lines. So the first argument that is passed to this statement is the statement that we'd like to check. But if we were to say here comma and use a string to say, actually a formatted string, and I can say price and then refer to the value of it is not greater than 0, like that. I can add an exclamation mark here, and I can use the same thing, copy that with a comma, and paste this in here, and change this quantity, and then refer to the value of it, and say that it is not equal to, greater than or equal to 0. So it needs to be actually changed to greater than or equal to, like that. And same goes for here. And I have some space here that should be deleted. All right, so now if I was to execute our program, then you can see that we receive assertion error, quantity -1 is not greater or equal than 0. So I should delete this then here or that, and now it is perfect. So now we understand that using the assert statement could allow us to validate the arguments that we receive, and also it allows us to catch up the bugs as soon as possible before going forward with the rest of the actions that we like to take within this program. So let me actually change those back to valid values like that, and that is perfect. So I hope you learned something new in that episode. In the next episodes, we are going to focus on more object-oriented programming terms like class attributes, what is double underscore REPR, and even more. So I hope to see you around in the next episode as well. Don't forget to hit the like button if you enjoyed in here, and as well as subscribe to my channel so you will never miss a content. See you next time.